Welcome to this episode of Let's Talk, where we zoom in on the practical implications of the session we saw earlier in the Congress about big data and artificial intelligence in implant dentistry. My name is Gerrit Heijkoop, and I'm very honored to be joined by our three expert speakers from the session. Let me introduce them to you. It's Andreas Dengel, who is the Executive Director of the German Research Center for Artificial Intelligence. Welcome, Andreas.
Yeah, thank you.
Glad to have you here. Your talk was about the future of digital data. Mm-hmm. Next up in the session, we saw Tim Joda, an implant dentist, a prosthodontist and periodontist, but currently also the head of e-health in reconstructive dentistry at the University of Zurich. Welcome, Tim.
Welcome, thank you.
And our third talk in that session was with Arjan Vissink, who is an oral and maxillofacial surgeon from the University Medical Center in Groningen. Welcome, Arjan.
Yeah. Welcome.
Okay. We are going to look at the change that big data and artificial intelligence might bring to the clinical practice of implant dentists. But let's start with the beginning. We had a talk on data, two talks on data. We had a talk on big data, a talk on artificial intelligence. If you're in the network reception later today, someone missed the session, what's actually the difference between big data and artificial intelligence? Big terms.
Data is data, and artificial intelligence is algorithmic technology, which is dealing with the data in certain granularities. Of course, data is also not the same. We have very unstructured data, censored data, to very structured data in databases. And the information value is on one hand side higher. So meaning that at the end, we have special cases, which doesn't mean that we need that much data at the end. And here we have unstructured data, which is unlabeled, where we don't know about the features. And this is the entire spectrum that toolbox of AI methods has to deal with.
Exactly. Tim, would there be any artificial intelligence possible without big data?
Hard to say. Data is necessary. Big data is a huge term. So what is big in this kind of definition? But let's say in a easy way, we need a lot of structured data. That was Andreas said. Mm-hmm. And this is the big issue. We have created tons of data, even health data. Nowadays, such commercial brands like Apple using their watches, creating health data. But is it all structured? No. For applications that we want to apply in medicine, then we need highly structured data, and this is the big issue. And I couldn't agree more what Andreas said. So it's a kind of toolbox with the AI created algorithm, and the other sense it's a substance, the backbone to feed this system.
Exactly. Now, Arjan, you tried to give us an overview of the availability of big data in specifically implant dentistry.
It's very
limited.
Very minor.
Before you kept on summing up study and said, well, it could be an interesting attempt, but not enough data. What is your key message to our audience here today in this Congress? What do the implant dentists, and specifically those in research, need to do?
First, to make a proper data set, just first to think about what should be in the data set.
And is that just the more the merrier?
Not the more the merrier. It should be data which are quite easily to produce, and not so much put in all data.
Okay. So
because there's a difference between big data and data. Data for studies, you can very good, very well structured, but big data is more the general practice. And that's something.
Lacking. Andreas?
Here can I add something. I think it depends from case to case. If you talk about big data, this is not just the volume. Mm-hmm. There are a couple of definitions, but it's the velocity, it's the variety, for example, the major dimensions, and then it's case dependent. How much do you know about a domain already? Which means that maybe if you're unknown.
When you mention case, Andreas, you mean to what field you're applying it, right? Because when dentists talk about cases, it's about individual cases.
It's a different talk, yes.
Maybe a novice in this, but yes, I think about the domains and the applications, and that's quite important. So if you don't know too much, it's better to have a large volume of structurally collected data in a certain way, mostly diverse, so that the sample has a good distribution among it. And if you already know a lot, you might need less data.
Aha. The more you know, why is that?
Because you have a lot of background knowledge where you already have experience in how to cluster, how to categorize, and whatever is necessary.
So the data is less messy.
You could do a pre-selection exactly, but most important in our field, in medicine especially, is the harmonization of the data. I think we have punctual data collections everywhere, and there's no initiative to build a standard, because standardization is another challenge, because people have different opinion, what's important on the data, but harmonization is the key.
Exactly. So it's important to have a big data or a large data set, well structured, well understood. One of the questions that came during the session from the audiences was, can't we just get rid of all that need for standardization and classification, because can't we just go on a continuous scale of algorithm outcomes? Tim, what did you think when you saw that question coming in?
Yeah, this would be the wish, of course, if it would be just easy. And nowadays people think, okay, there we have an AI toolbox, we take this, and then we get a nice algorithm and there comes something out.
Magic happens.
Yes, but that's wrong, or that's the misunderstanding of this procedure. And,
why?
Yeah, as Andreas said, it is so important to have this structured data. Or let me compare it maybe with cooking. If you start cooking and have the wrong ingredients for a specific dish, then it wouldn't taste like it is as this dish. So it's so important to start with the right data from the beginning that is in need for your specific task.
Exactly. So, and we need someone, we need an initiative, that's scary to ask in a global conference like this, for someone to start structuring that data and give proper classifications. Let's move all the way to the end, to the clinical practice. Arjan, what do you think that is the most impactful change? Pick one, because you all shared many examples. But what is the most impactful change of either the large data sets that you talked about or the use of artificial intelligence in clinical practice?
That's difficult.
I know. That's why we talk about it here at this table.
At this moment, the most impactful was more, for example, that study in Sjögren's patients, because that was targeted. All patients were really well diagnosed, and you collect all data of implants. The other studies were just huge data sets, and you just get general trends.
Yeah. So you say the biggest impact of a large set of well-structured data could be that we actually could start to draw some conclusions on all kinds of trends, you showed in your talk. Nice. That's something to work for. Yeah. Tim, biggest impactful change specifically on artificial intelligence?
Yeah, I think it's great to have such a tools supplement your routine clinical work. So it can help you to make your life easier right now. And this is maybe invisible. So nowadays it's a kind of buzzword and the mega trend, and everybody so published somewhere and sending manuscripts to the journals, and there had to be digital dentistry or artificial intelligence, but nobody knows exactly what it means so far. It's my meaning right now. And but I see a big advantage, as I saw, to get work done by a machine that the human is not doing in a predictable manner. For instance, to have radiological, like X-rays imaging, then you can use it to have a pre-diagnostic analysis of this. And this can be done all time, and no human is able to do so in a large scale, and this could be automatically done. Or implant treatment planning, all the pre-settings. So we have seen as a cone beam CT is quite complex, and to focus on all these areas. For diagnostic reasons, it is quite easy to have an AI tool to diagnose these areas, and then to give an example where we have to look on more in a closer view. But you have to emphasize, it will not replace the human. It is always necessary. It will help the way to it, but then you have the final check by a human as a professional.
But isn't there a risk that the human becomes lazy over time.
Yeah.
So now in the early Andreas, right?
That's
because
a human,
now we think we should be
factor.
careful.
Yeah.
But then after 2 years, 3 years, like, the AI is always right.
I trust him, and the machine will be
Andreas,
better. Yeah.
I see you recognize something
Yes,
in
this
this.
is a big danger. If you
It's
look at
dangerous.
GPS systems, which were introduced many years ago already, but at the beginning many people were skeptical and used their
Hold the map
physical
on the
maps,
side,
and to see what's going on. And these days we're just going to the car and say from A to B.
But you say it's a big danger. Why would it be a danger in, for example, dentistry?
Experts tend to optimize everything, and if there's a tool which makes it happen somehow after a certain time, and you can trust or you build up trust on the tool, then it happens. But let me also address another dimension, because I think what was said by Tim, it's quite important to have this grassroots view on patients by the experts. But we are also lacking in having this bird eye view, where we are having not enough insights, because from a single patient up to a population, it's a big step of complexity which we cannot capture. And for this purpose, there is another AI dimension which is quite important. If you look at the large language models, which nowadays are not just classifying nor transforming, but they learn by themselves by just reading. So we have a one-dimensional, very well-known text. We know what we're doing.
For example, all these abstracts and papers submitted into this Congress.
But now you can also see some fields in medicine, for example, in genomics, where you have a kind of language behind it.
You mean genomics is the language? Or
encoded in...
Exactly, in the human body?
Exactly, it's encoded in strings, and this is very similar to language. So what you could do is, if you train a lot of different genomics, the system could also recognize patterns and interrelationships where they put some attention on, to see what happens, and then maybe later could, by reading all these different genomes, and it could later on also give a kind of advice for medical doctors. This is something which I expect which will come quite soon. We will have foundation models for proteins, for DNA, for RNA, and maybe for peptides as well.
And if we translate that together to the clinical practice of an implant dentist, Tim, if an AI tool just scans your patients and gives you based on a large overview.
Yeah, maybe we think about, and I brought up this term, personalized implant care, so that we see nowadays we act in an evidence-based model. So we have some kind of data achieved by clinical trials, and then we say,
Which is in the field of dentistry always tricky, because each case is different.
Yeah, but this is the pathway, and we can do so when we follow this roadmap. But in the future, maybe we distinguish our patients, and we have tools, and we can see what works best for this patient. For instance, receiving an implant with an GBR, so a bone augmentation procedure, and then we can see, this material combination, or this membrane, or this implant material itself might be in favor in this patient in contrast to another patient, combining the entire risk models. So maybe saliva samples, we can identify some proteins or something inside that makes it specific for this patient, and that will change our treatment. But we are not there. We are not there. But this might be something. I'm just a clinician, so I'm not aware about all this stuff. Yes, this is the blueprint, and there is something to mention and to say, it would be nice to have something like this.
This is very hard in saliva.
Arjan, I see you nodding heavily. What do you think when Andreas introduces the AI reading our genomics? What opportunities do you see for dentistry?
I couldn't understand his talk. It was so bad, the noise.
No, but right now, Andreas says the future of AI and data, what I see is the AI model will learn to read our genomics, and based on that, be able to give us advice, right? Proactive advice.
It's an advice. The same for the evidence-based dentistry nowadays. Because at a certain moment, you can do it. But you have also cases in which it doesn't work.
Exactly. So that remains. Tim?
Yeah. But you have to consider, and I think there's a great opportunities, but for instance, do we want to know everything what will happen in the future?
Mm-hmm.
This might be a tool. So it's an ethical question, of course. And if we apply such or develop such a tool and apply and get the results, who do we have to tell? How will we deal about this? So what are the consequences for our daily lives? And this is another issue. So we have a lot of opportunities, and maybe not the next year, but in the 5 to 10 years. But then we have to change several other ideas around this concept and how to deal with this kind of knowledge we will gain.
I would love to go into a full other episode of Let's Talk on the ethics of AI, but we promised you that this would be a teaser into the session. Yeah. So let's end with a practical note. How far away from the clinical practice is this? You showed us a lot of examples. You are also still in the clinic as well.
Yeah.
Do you already have any AI tooling around you?
Yes. So that was shown for the treatment planning. We use an AI assistant. So you upload the cone beam CT of the DICOM data, you upload your intraoral scan, the STL file, and then it will automatically pre-setting that we have the nerve identification, and we did some preliminary results that we focused on the humans performing this task and the AI algorithm, and it's 10 times faster, the machine, and more predictable. So if we want to repeat the same, we're getting better results.
But then you have to refine it.
To define the results.
Refine.
Refine, yes, a little bit, and confirm it. But this is something we discussed a few seconds ago. It is surprisingly exact. So it's really good.
Exactly. And Tim, all of you are here as experts working in an academic setting.
Yeah.
How difficult is this to bring into my own clinic? I mean, is it expensive? Is it a big learning curve? And without naming any brands or companies, like, how far away is this?
So it is commercially available for specific tools. And I think the 3D implant treatment planning, this is the opener to the further steps. So treatment planning and then the surgical procedure, it belongs to each other. And so I mentioned it, without the three-dimensional planning, it is not possible to go for guided surgery, for dynamic navigation, for robotic assisted surgery. So this is highly linked to each other. And of course, this will imply you have to invest. You take money out of your pocket, and this is the good thing at
Finance
the university.
And time, right?
But a lot of people and the dental offices outside, not working in an academic environment, they always say, okay, when will be the return of investment because scalability and so on. This is the decision everybody has to take. And it depends if you are a single worker in a small unit or a big chain as a DSO, then of course there are different money in the background, investment chances.
Of course.
But it will divide dentistry in the future, and it will help to harmonize the treatment quality.
Exactly. So I hear you say, get started, right?
Yes, I think so. I think so.
So we have
not to make money.
No. The interest should be to put the patient in the foreground. So clearly say that. So and do some patient-centered treatment.
Exactly.
Yeah.
So Arjan, you have a clear call to action to this audience to say, start collecting your data, classify as much as you can, and put it in implant dentistry relevant categories.
Yes, but first make together an outline of a data set.
Yeah.
Not
who is in the lead, Arjan?
I think we have to start it now.
Here, right at this conference.
At the conference.
Sit together
and start it.
Okay, that's an invitation to you. If you're watching this later on, let's find out how that works. Tim, your call to action is very clear. Get started, and it's an entry to develop further opportunities. Andreas, as a relative outsider in this field, deep into the research of artificial intelligence, what would be your final call to action to our audience?
Oh, difficult to say, but such an audience as it comes together today with so many players from various countries, many backgrounds, I think this is always a good start for initiative, to find stakeholders and working environments to define things. But at the end, you can see that the concentration nowadays, also from investment money for medical applications and startups, is increasing.
There's
and
momentum.
We see exponential publishing also in this field. And we can expect in the next years big advances in all fields of health. And I hope also in dentistry.
Exactly. Well, thank you all for taking the time for this Let's Talk. If you just clicked on this video and you're starting to get curious, make sure you check out the full recording of our first plenary session, which was chaired by Henning Schliephaken and Iva Milinkovic. This is Let's Talk for now. Looking forward to see you in the next video.